my name's Ajit Kaur-Sucha. I'm the Commercial Business Manager at REAS Group. REAS Group are hosting today's GDG-MK, our second meetup actually, at the lovely Aiimi offices in MK. So Aiimi are a leading artificial intelligence organisation, and for those of you who are here today and aren't part of the Aiimi team, you can see how incredible their space is. So yeah, it's great to see some new faces in the audience, and welcome to everyone on our live stream too. Today we've got 3 incredible speakers lined up for you. Today's presentations will be following the same kind of title as last time, the working in technology in MK and some tips and tricks. So today we've got Jack Lawton, who is the data science principal at Aiimi. We've got Georgina Hodgkinson, who is a software engineer and the founder of Ask DT. And then finally we've got Karsten Silz, who is a full stack Java developer. So if you did miss our last GDG-MK meetup, you can actually catch all the previous content and sort of presenter slides via the GDG-MK KonnekApp. The app is available to download on the same link you would have used to sign up for today's event. So KonnekApp is something developed by REAS Group, so if anyone needs any help downloading it or signing up to it, please do get in touch. Other than that, we hope you really enjoy today. We've got some really interesting presentations. I'm sure you're going to learn something new. And do stick around at the end for some networking. It's one of the brilliant things about these events. We get to meet other professionals and some amazing opportunities come off of the back of it. So without further ado, I'd like to welcome Jack. Jack.
Good evening. Hopefully everyone can hear me all right. Is the microphone working? Brilliant. Fantastic. So hi, I'm Jack, and I do have some slides. So today I'm going to be talking about how to design smart algorithms, and specifically I'm going to be covering over a piece of work which I've done for a real customer, that is Anglian Water, related to some hydrophones they've had deployed on their network, and how we can design algorithms to better deploy those smart devices. So by way of introduction, this is me. So I've got a background in physics, and for the last 6 years I've been working in data science. A couple of my more recent customers include the Department for Business, Energy, Industrial Strategy, and of course Anglian Water. So I work for Aiimi. I'm data science principal here, and I see exactly where we come to you live from. Aiimi's fantastic offices in Milton Keynes. And of course I'm presenting for the Google Developer Groups. Now, those of you who read the title to my presentation probably guessed, or may have guessed, that this is a graph. So a graph is a mathematical sort of way of representing data, and it's defined as a collection of nodes and edges. So you can see the nodes are the circles and the edges are the lines. So nodes are connected by edges. Nodes can be different types of things like places, people, organizations, and the edges link them in various different ways, which can also have data associated with them. They can also be directional. So I'm employed by Aiimi. I do not employ Aiimi. It's probably worth at this point making it clear that this little thing here is a chart, not a graph. So whenever I say graph, I do not mean this. I mean the little thing with blobs. So I'm talking about Anglian Water, which is a customer I was working on a project for. Any of you who live in Milton Keynes probably know Anglian Water because you'll get your water bill from them. They do also cover other areas in the east of England, Cambridge, Ipswich, Great Yarmouth. But most importantly of all, it's actually a very, very flat region, which means that they've got a lot of long pipes and they have to pump water long distances, which makes this problem really significant for them. So leakage refers to water that goes missing out of pipes between source and your tap. So actually 20% of all water put into supply in the UK goes out as leakage. That works out as about 3 billion litres of water a day, which is obviously huge. And when you think about the pressing issues of climate change and population growth, getting on top of leakage is a really important issue for the water sector. And that's been recognised by the regulator, so they set increasingly tough targets for UK water companies to deal with leakage. Of course, Anglian Water is no exception. So, the tricky thing though, water networks are not simple. So this is somewhere in Lincoln City Centre, I think. It makes up a significant portion of Lincoln City Centre. And this sort of scale that you're looking at here, all these different pipes, is the sort of scale that water companies are typically able to narrow down where they think they might have leakage. But then they have to send guys out to work this entire network to work out where they may or may not have leaks on each individual pipe. So the question is, can we do something a little bit better? So one of the ways that Anglian Water are trying to solve this problem is by using hydrophone sensors. So these are cool pieces of kit, you put them out on your network and they will literally listen to the water in the pipe, and you put 2 of them on either end, and because they have synchronized clocks, they can correlate where they think the leak is actually coming from. That's really cool. And these are smart devices, so you cover an entire water network with these devices, go away, have your cup of tea, you come back the next day and the devices would have told you where all of your leaks are. Which is fantastic, and it's so good that Anglian Water have trialled these and they want to lay them out across the majority of their network. The problem is they're not very cheap, so they need to be smart about where they put them and how many they use. But as we said, water networks are complicated. This is not actually a trivial problem to solve. As you've probably guessed it, the solution is turning it into a graph. So it's a little bit different to the graph I showed you earlier, in that this graph, the edges are what's really important. The edges represent the pipes, and the nodes, connections between those pipes. Because we know about these edges, the length of them, and the material, which is important for understanding the speed of sound along those pipes, we can understand if I put a hydrophone on the network, what area of that network it would be able to hear. Then, if we want to be able to correlate noise to that hydrophone, we need to put another one. And the smartest place to put it would be somewhere on the edge of its detection range. But now you can see there's going to be a problem here. And there's 2 different ways we can correlate sound between those 2 hydrophones. How do we know which one is going to be the most effective? Of course, they are going to hear in both directions, but how do we know what is the shorter path and therefore the more likely cause of that leak? And this is critical to how the whole hydrophone algorithm works. The answer is we need to find the correct path, or the shortest path. This is where I like to play guess the mathematician. I'm hoping Dijkstra. Bingo. So a primed audience. Dijkstra was a Dutch mathematician, and he came up with a very popular algorithm for path finding. Other algorithms are available, but this is quite an easy one to describe. There's an excellent little graphic here, which I've stolen from Wikipedia, one of my personal favourite sources for information about maths. You can see how the algorithm works. It's starting from the red corner there. It's building out paths in all directions. Now, all of these paths are equal length, so every time it brings them out in different directions of equal length. You can see when they hit the obstacle, they turn back on themselves, and when a path has to turn back on itself, it goes over somewhere that's already been covered. And that means it's no longer the shortest path to that destination, so it gets stopped. And when any one of those reaches that green dot, which is the destination, then because it's the first one to have reached that green dot, it's also by definition the shortest path to that green dot. Hopefully that was concise. You can check out Wikipedia if you would like to look it up. So I've used a Python implementation of that algorithm, and you can see here I've taken a real water network and I've plotted it using matplotlib. So what I can do with this network now is I can put 2 sensors on it, and I can colour in red there the shortest path between those 2 sensors. It's fantastic. Of course I could put those 2 sensors anywhere on the network. So how do I choose those 2 places to put it? Well, the starting point, we're going to use something called centrality. So I've plotted it here in green, so you can see the brighter green areas have a higher centrality. And I've used the betweenness centrality here. Other centrality methods are available. But betweenness centrality is highly useful here because it's defined based on shortest paths, which is how these hydrophones are working, how the sound travels through these pipes. So the betweenness centrality is the number of shortest paths out of all possible shortest paths that pass through a point on the network. So it turns out that the most shortest paths pass through that particular point on the network there, that junction there. So that seems like a sensible place to put our first node. There we go. But what about the second node? Why have I put it there? So I've put it 500 meters away from the first node. That's because that's the sort of characteristic detection range I'm using for this exercise. But you can see I could put it 500 meters in any direction from that node, and it doesn't really matter. I'm not really achieving very much. The problem we've got going on here are these 2 little sections here. You can see those little straggly pipes come out. And if I want to get a shortest path on any of those little straggly sections, I need to put a sensor at the end of one of those straggly sections. You can see there's a lot all over this network. So I'd need to use loads of sensors if I wanted to achieve that. This is where we have to step back from the pure mathematical approach and thinking about the practicalities and the business context of how this works. So these sensors here, they're correlating to the sound of the leak. You can imagine if there's a branch, they're going to correlate to the junction that that leak is on. Now, provided that little branch isn't too long, then for the guys in the field, it doesn't really matter. So they can go out and they can say, right, if that pipe's not too long, then I can find a leak anywhere on it. So that's brilliant. So what that means is we can code those business rules into the algorithm. And I've gone away and done that. And then we can color in those sections. I've done that in blue. So you can see that they will be covered separately to the shortest paths rule. But now it might become obvious why I've put the second sensor there. And that's because, including those little straggly bits, that's the best place I can put a second node. I've considered every point on that network where I could put a second node. And that one is the best place because it gives the most additional coverage, which is all that area coloured in there. And I can ask the computer the exact same question again, right? Given this coverage and these nodes, where's the next best place to put one? Where can I get the most additional coverage? It's there. I can ask that question again. It's going to say it's there. I could ask the question again, there, and again, and again, and again, and slowly build up coverage on that network until I feel I've got an acceptable level. Now, some of you are probably thinking, maybe this is not great. This is actually what's known as a greedy algorithm. A greedy algorithm will always choose the best possible option that it can choose. So it's always going to look for the most gains that it can make at any given moment. And it's going to make mistakes. So if you look down here, it's put those two sensors very close together. And now a human probably wouldn't do that. A human would probably say, well, no, you should probably put another one of those up there because you get better coverage overall. But because of the way the greedy algorithm places those sensors down there, it's not been able to see that. So the fundamental issue, just to reiterate that, is if I've got a little H like this, if I put a sensor in the middle, that's the best place for one sensor. The next best place to put one given that is probably on either side. But the optimum solution for two sensors looks more like that. And that's the sort of algorithm we want to design. So how can we plan better? This comes to thinking about chess, or any kind of puzzle game really, but how you might play chess. So imagine you're in this position in a game of chess. And imagine you're Mr. Greedy. What Mr. Greedy's going to do is going to say, well, my queen can take the knight. So he's going to take it. But then Mr. Greedy's going to be very disappointed because he's going to lose his queen. So if we take a step back and we imagine we're not Mr. Greedy playing chess anymore, we're Mr. Clever. Now, Mr. Clever is probably going to say, well, what if I move my bishop out here? Now, provided black doesn't see it, which I'm going to say he doesn't, then Mr. Greedy can say, sorry, Mr. Smart will say that we'll take that pawn with our knight, and we've got checkmate. And now Mr. Smart has been able to see that, been able to look ahead and understand that that is the optimum way to play that game by thinking more than a move in advance. And that's what we want to do with our algorithm as well. So if you think about placing sensors, essentially we've got a series of decisions that we want to make, and each decision is going to give us a different amount of coverage in meters by placing an additional sensor. Mr. Greedy looks at this and he only looks at the top row, right? And he says, right, 200 meters, that's where I'm going to get my first saving. So he ends up right down there at the bottom at 300 meters, which is okay. But Mr. Clever's just going to look at the bottom row and go, actually, the bottom row, 400 meters, so I'm going to place the sensors in these locations because that's better. So that is exactly what I've done. I've implemented an algorithm that will look at all the possible places it can put sensors, given the first one, and it will optimize. So you can see that now it's starting to second guess itself. It's moving the sensors around so that it's not just placing the next best place, it's finding the optimum solution for that number of sensors. And again, we can carry on through this till we get to 8, which is what I've gone up to, and you can see it's got a much better level of coverage for the same number of sensors, and it looks like something a human might come up with. So, you're probably also thinking, surely, Jack, that's not very efficient. So if I wanted to place one sensor down, right, we're getting that one for free because I've chosen the most central point. Fine. Second sensor, that's going to cost us, say, 50. Let's say there's 50 different places I can put a sensor. So I'm going to need to consider all of those and how much coverage each one of those places gives me. If I want to put down the third sensor, I'm actually going to need to second guess where I put the second sensor. So that's 50 by 50, which is 2,500. And then I put the third one. It's 125,000 because I need to reconsider 3 positions. The general rule for this is 50 to the n minus 1, which is an exponential sort of graph. Essentially, it means that it's going to get more complicated very, very quickly. To put that into context, if I wanted to put 10 sensors down and each calculation took 1 second, we're talking 60 million years to compute the solution. Because obviously, not going to work, right? So how do we cut this back and start to save time? So what we can do is something called pruning. So if we look at the tree and we look where we're making decisions, actually, Mr. Greedy takes a very severe approach to pruning where he only ever looks at the top row. But if we can look just one step ahead, or a couple, we can say actually at this level in the middle, we've got a suboptimal solution. So it's unlikely we're going to see the best solution down one of those paths. And we can do that to essentially whatever extent we like, to tune down the number of calculations to a more palatable number that we can actually crunch through on our computer. This is exactly how chess algorithms work, to sort of go back and do the chess point again. If I'm in this position and I take this pawn with my queen, I'm going to lose my queen, right? And in chess, you would say the queen is worth 9 points. And that means that we can actually associate the value of that move, right? We've lost our queen, so it's a terrible move. We know that. And we can say, actually, we don't need to explore any moves beyond that one because we know it's a bad move already. But all the other moves the queen could do might bear more fruit, and maybe we want to look 2, 3, 4 moves into the future. It's a little bit more complicated because obviously black might do something different. If you want to look into it, it's a technique called alpha-beta pruning, very similar to what I've done. So the general point here is we move from something that looks like e to the n, an exponential curve, to what I've done is I've forced it to be linear. So we're looking at a fixed number of possible opportunities each time. What that means is it's industrializable. So we can actually make this reality, scale it, deliver it to the customer. So what I've done, I mentioned earlier, I did this in Python. I turned it into an API using Flask as a REST API that links into a Power App at the moment. And now business users come, and they can request deployments for specific areas. And here you can see it's slightly different to how I was showing you. I've made a little bit more business context around it. I've colored the pipes based on their material, and I've put on postcodes instead of numbers so that technicians can stick it in their sat-nav and they know where to go put the sensor. And I can prove that's real now. It's delivered results. So this was a quote from earlier on in the program, and you can see that we've delivered efficiency of over £250,000 by being a little bit smarter, using some clever algorithms. One more thing. If you wanted to have a go at this yourself, you can. So I've used NetworkX in Python. If you wanted to do it in R, there's something called iGraph. If you wanted to get really serious, there's also something called Neo4j, which is a fully fledged graph database available in Java. If you are curious and you would like to do things like this, then actually, Aiimi are hiring, and I believe there's an ad break now, which will give you some more information. Thank you very much.
It's refreshing to work at Aiimi. It's a very open and transparent company.
The amazing sense of community that we've got within the company.
Culture of respect, of being responsible.
We are encouraged to challenge. We are encouraged to come up with new ways and ideas.
And also real recognition.
It's the opportunities to be yourself and shine and not feel restricted.
Self-starters, high energy. One of the things that we have learned as a company is to go and look for that thing that someone really loves doing. And we try and steer people to do more of that and less of maybe what is in their job description that they don't want to do.
The company appreciates that not everyone works in the same way. If you need a bit of flexibility to do the school drop-off or pick-up like I do as a single mum, then I have that. We will work with you to make sure that your working environment is what you want and need.
The new office embodies what Aiimi stands for.
It's a really creative space.
First thing that you see when you walk through the door is a communal space that's super welcoming.
I was surprised really when I first came through the door. I was like, it's quite open, quite relaxed, and it's very modern.
To come out here, Milton Keynes, and come into the space, it's a breath of fresh air.
We wanted people to come in, smell coffee, feel like a warm, relaxed environment.
Essentially, we are a lovely bunch of people that like to spend time with each other, and we do that in work, we do it out of work. We've had people that go away on holidays together, so we like to let off a bit of steam, and normally we do that with our monthly team meeting, and we'd have activities like bowling and karaoke. We have an away day every year where we've done things like whitewater rafting. I guess the company's giving back to us. It's a thank you for your hard work. So So we wanted to make sure we had a really inclusive environment that was accessible to everyone's needs and abilities.
There's lots of really great initiatives that Aiimi are behind. For example, the Diversity, Inclusion and Equality Working Group, of which I'm part of.
People from all races, genders, ethnicities, personal preferences will feel comfortable being themselves in this working environment. This to me feels like we've got the excitement and the energy of a startup, but with the safety of being an established business.
Thank you for your presentation, Jack. That was really, really interesting. And Aiimi looks like a lovely place to work. So if you are interested, please do head over to their website. I'm going to introduce our second speaker of this evening now, Georgina Hodgkinson. So Georgina's presentation is all about how we in the software industry can help contribute to the UN Sustainable Development Goals. So really excited for this. So I'll pass over to Georgina.
Thanks very much, Shadi. I've got a video, if we can play that. Thank you.
We're all connected. We share a common bond. To our planet. To each other. But now is the time that we need to come together. Because it's our ideas and actions that have the greatest power to make an impact, around the block or across the globe. What started out as a single developer challenge has turned into a global movement of problem solvers and innovators, united in strength by code, using open tech as a force for good. Our creativity has helped us challenge Mother Nature, stand up to climate change, and rise above hate. By joining forces and harnessing technology, we're building life-changing solutions. From Barcelona to Brisbane, Nepal to Nigeria, giving hope for generations to come by tackling the world's greatest challenges. Because together, we can make a difference. Together, we can answer the call.
So I'm going to be talking about the role that software can take for the UN Sustainable Development Goals. First of all, I don't like talking. This is not my natural comfort zone. But I have started, since 2019, a Toastmaster group that is local, that is trying to get very technical people to give talks. So if you're sitting there like I was a few years ago, not wanting to speak, but having to build up that confidence, there are safe spaces that you can go to do this. And it is hard when you've got people that are very good and proficient at doing this, when standing up here is very nerve-wracking. So bear with me. It's something that as I say, it's not my natural comfort zone, but I'm working on it. And this is where I think it's important to be genuine and who you are, to sort of come and give your experiences and skills. So a bit about me. Ooh. I've done that as in for the protection of my children, obviously. Maybe it's just not a good graphic. I'm a very busy person. I have 5 children. It's not something I lead with, but it's, again, part of being who you are. And I've been in tech a long time. I dye my hair, I'm covering the greys. And I've seen it evolve for quite a long time. And my dad was an electrical engineer. And before I knew it, I was coding at 7 years old on little Commodores and having little pixels jumping around on screens. I've worked for Abbey National, that is now Santander, which is local to Milton Keynes. I worked for law firms and how they changed from little green screens to now mouse and now iPads, etc. So I've seen a lot of changes. But I also work in a lot of the third sector and sole people that work for themselves, sole traders. And I go along to a lot of tech conferences. In fact, wherever Robert is, that's where I met Robert, at BSI, at the GDG, and when he was learning and showing his skills on what he'd learned about Flutter and Firebase. So it is important to stand up and share the skills, even if you don't think that you're ready, comfortable, and we're all looking for those safe spaces to do that. But the main bit of my talk is about the Sustainable Development Goals. If you don't know, this is going to be a whistle-stop tour of them, because I could spend a couple of hours before Ajit pulls me off to say, no, that's not something we've got time for today. But we've got 17 UN goals that were in 2015 seen to make the best what we can do global focuses. And there is a lot to them. And if I was to go through each one of them, IT, tech, code empowers all of them. But I learned a big lesson back in 2018 when I was coming back after having a child and having to retrain. And I did a summer of code. I don't know if anybody know that Google also does a summer of code. And for 90 days or over the summer, you work on a project. So in 2018, I worked on a project which was a hospital information system for third world countries. Balmy. And we had fantastic mentors helping us and supporting us on how to do new ways of coding, etc. And I'll admit, when I first started coding, I was just grateful that it compiled without any errors. But then my mentor from Germany, Ivo, was saying, re-look at the problem. Look at it again. How can we make this more efficient? And as we've already heard from Jack, these algorithms, these coding can be more efficient. Because when we're looking at software, we also need to look at what devices they're going to be running on. So although software, yes, is carbon-free, what they're running on, the devices, the hardware, not everybody has the latest and greatest processors, RAM. They are maybe out of use for first world countries and have been cast down to third world countries, but they are still usable if we change the software. So that started opening my eyes to how we code, what we code, how we design our code. Yes, we love obviously pushing the boundaries and looking at all the graphics that we can possibly use and making it nice and swish. But is it also functional for the users? Has anybody heard, I'm sure people have, just by a show of hands, Google Lighthouse? Anybody heard of Google Lighthouse? A couple of you have. Who's heard of SEO? Okay, everybody's heard of SEO. We want to create things on the internet that is optimized, and normally we want to optimize it for Google. Okay, we want first page rankings. Okay, but Google Lighthouse will look not just at your SEO, but it has committed to the SDG goals and is looking more and more with its algorithms of how performant your apps and your websites are. And you can use Google Lighthouse. It's in the developer tools, and there's a tab on Google Lighthouse, and you can put in any website and you can see how performant it is. It's a really, really nice tool. But just to come on to this, I've got Walmart there. It's not just about saving the planet and reducing the carbon. It also makes it a better user experience. We all look at how fast our pages load. If it's going to take time, we're going to bounce off. We're not going to do that. So performant pages and apps make sense for our end customer as well. There's a lot of skills that we need to learn as developers and as engineers, and there's always trade-offs. And there's lots of local projects that are always happening. One that I took place recently was the Green Roof Hackathon. Have anybody seen it? Where we had Raspberry Pis on a roof to measure rainfall and temperature to see how much a building was losing. And that was something that we arranged Milton Keynes locally. There's also a lovely group that are looking at donut economics. If you haven't done this already, look at it, because we're not looking at growth, we're looking at infographics where we are looking at a circular economy. Okay, and some other companies or organisations that I work with, and we're looking at in October for Ada Lovelace Day to do a data detective day, and that looks at what data is available and what we can use locally and how we can make some changes. There's also a new organisation and new terms all the time in tech, and there's the Green Software Foundation. Do you want to be a green software engineer? This is a really good facility to use, because they're going to start looking at how do we start measuring performance of an app, which is very complex, depending on what tech stack you're using, what algorithms you're using. And they're looking for people to help them build up these specifications on how much software as a carbon is making impacts to our environment. And one of the things that their quotes here is, everyone has a part to play. Whether you're a designer, are you designing it for sustainability in mind? And I know there's a lot to take in place, but the big message here is that sustainability makes your apps, makes your code better. Get rid of old code that's not needed. Don't have it legacy there waiting around just in case. When you build your software, you're not bringing in the whole library, you're just bringing in the part that you need. And there's lots of other things that we can do, and I think this is just to start the conversation without me sounding like I'm lecturing. And we're not all, performant at the moment, but it's, again, coming back to, if we can measure it, we can manage it. So let's start measuring it and get better and help the planet and us to build better performant software.
Wow, thank you, Georgina. That was a brilliant presentation. I think we all understand that we all need to be stepping up our game and contributing to the UN Sustainability Development Goals. The ad that was just played was for KonnekApp. That was developed by REAS Group engineers. It's a lead generation app. It allows you to display your various forms of digital content, video, presentations, PDFs, Word documents and such, even live streams actually. And then the best thing is that you get all of your user analytics and it presents back to you with information on who your warm leads are, who your hot leads are, and who the cooler ones are. So you're actually knowing who is watching your content. So if you do want to find out more about that, please contact anyone in the REAS and KonnekApp team or chat with me afterwards. So I'd like to introduce now Karsten Silz, who's going to be giving us a really interesting presentation on a Flutter app that was designed for cat sitters. So looking forward to this one. Karsten.
Okay, well, thank you for the nice introduction. I got some slides too, so please switch over. Here we go. So I want to tell you today what I learned from building a Flutter app for cat sitters. So how will this make your life better? You will learn how to build a better mobile app. And I'm going to help you in two ways. Number one is I'm going to tell you what Flutter is, and number two is I'm going to tell you what I learned about it, you know, as the title says. So why should you listen to me? Why should you care? What makes me showing up here? Well, I'm a speaker at the biggest Java conferences in the UK and Germany. I also work for InfoQ, the site you've probably seen, and I help organize the next QCon London conference in, next week. I use two projects that I'm going to be talking about here, Angular and Flutter, but I'm not associated with them. And I'm not trying to sell you a book or training or something. But no matter what happens in the end, I can tell you things all day long, but in the end, you decide in your project. So I've got a talk page with sample code and videos and slides and more. You can find them at this QR code. You can also punch in the link. I'll show this QR code again at the very end. So I'm going to move on in 3, 2, 1, 0 seconds. Thank you. So back to the agenda. What is Flutter? Well, first of all, why do we actually even need Flutter? Well, you know, a couple of years ago, you know, maybe 20 years ago, 30 years ago, when I started developing, all you needed was just a Windows app. But, you know, then there's Mac people, and then there's Linux people, especially developers, and of course mobile happened, right? So there's lots of platforms that our customers use, and now you could go ahead and try and start building all the native SDKs, but you soon figure out, well, this doesn't really work. It's too expensive, too many developers, too many different teams, too many frameworks. So that's too expensive. That doesn't work. Now, what does work is if you say, well, you're going to go cross-platform. We're just going to have one language, one framework. You know, it's cheaper, and for the most cases, actually, that's good enough. So the most popular cross-platform, you can just barely see it sneaking behind here, is the web. So why is the web so popular? Well, it's the biggest stack that we ever had in the history of software development. You find many developers, you know, also cheap developers, cheaper than mobile developers, typically. The frameworks that are pretty popular there are React, Angular, Vue. If I don't know anything about your project, that's how I would recommend them in that order, React, Angular, Vue. But the thing is, it's hard to learn. You've got lots of stuff to learn. You've got CSS, you've got JavaScript, you've got HTML, you've got the framework on top, and then this whole tool stack with Webpack and NPM. So it's a lot to take in. So is there something that, you know, caters to people that don't want to do web? You know, there's a no web down there in case I'm hiding it right now. So yes, there is. Why would you need that? Well, typically if you have backend developers, right? You know, you've got Java. Thank you for moving me. So you've got backend developers, you know, Java teams, C#, .NET teams. If you have them and you want them to build front ends, then it's easier to take a framework that doesn't require learning web. So they don't have to go through all of that stuff. It also makes it sometimes easier to build native applications. So that's another advantage of using a no-web cross-platform framework. The 3 frameworks that are pretty popular there is number 1, Flutter, surprise. Number 2, Xamarin from Microsoft, and then React Native from Meta/Facebook. It's a lot of web stuff there, but when it comes to mobile, building mobile apps cross-platform, you know, it's the other big one. You know, it's the arch enemy of Flutter, so to speak. Okay, let's take a look at some code. I took the standard Flutter app that you get when you create a new Flutter project, and I modified it a bit. It runs on the web, as you see up there. And so let's look at the code. It's really simple. It's got a little text box there telling me how often I push the button, and then there is the button there. And I think the first thing that we'll see here is that you know, we've got UI as code. So you don't have a builder tool, you don't have a visual tool, you don't do drag and drop. There's nothing separate here. You really just write code. Thank you. So UI as code, and you know, really 2 parts. Number 1, these 2 things are on top of each other. So here we've got a column which has these 2 children. The 2 children are a text field and a button. And if you want to configure it, then you don't go out to a style sheet or something, but you just say, okay, I want to center this. It's an attribute, it's code, right? And then this whole thing is centered in the middle. How do we change something here? We change it with status and events. You see here there's an event handler. When I push that button, it increases the counter, and it's enclosed in this setState function, and setState is a hint, well, a pretty strong hint to Flutter, something has changed. And then if Flutter sees that the status has changed because that counter increased by 1, Flutter is going to go ahead and redraw the UI. It's not our code that does that. We just do it indirectly by saying the state has changed, and then Flutter goes ahead, redraws the UI, and paints the new counter. So you push a button and boom, 1 shows up. So, and that's what's called declarative programming. Really, we've got UI as code, we've got status and events, and the framework updates our UI. It's not us. So you say, well, declarative programming, you know, that's kind of like a newfangled thing. Is that really a dead end? Is there somebody else who's using that? And yes, there is. So if you look at the, you know, the iOS Mac world, Swift UI is also declarative, standard for about 2.5 years on macOS and iOS. In Android development, there is Jetpack Compose, nearly a year old. On the Xamarin side, we're going to get something in about 3 months called .NET MAUI. MAUI is an island in Hawaii, but it's also multi-application user interface. That's what they call that now. And of course, on the web, we had React that had that forever. So really, declarative is state-of-the-art here. Now, we can actually finally talk about what Flutter is. Well, Flutter is Google's UI cross-platform open source toolkit. It covers a couple of different platforms. Mobile has been stable for about 3 years. Web has been stable for a year. On the desktop, Windows has been stable for a month. And Mac and Linux are supposed to be stable somewhere this year. It's also working on embedded, but that's really, you know, not a very general topic. It uses a language called Dart. Dart is like a simplified Java tuned for UI building, but it also has things that Java doesn't, such as sound null, safety, and async await for concurrency. So it's quite nice. So I said that it's pretty attractive to backend developers. Why is that? I've got some code here, really just a Java class. And if we want to take that class, that Java class, and turn it into Dart, what would be the difference? As it turns out, not really a whole lot. So just with this little change, we've got Dart code. You would write Dart code a little bit differently, but what you hopefully see here is that Dart is similar to Java, which means it's also similar to C#. And that's why it's attractive to backend developers. They have a language that's pretty similar to what they already use, and they don't have to learn this whole style sheet, JavaScript, HTML, NPM, Webpack thing. Okay. In Flutter, libraries are called plugins. There are, you know, a whole bunch of them, a nice portal, and they're pretty nice to use. They also survive. In Flutter, Flutter doesn't use the native UI elements, it emulates them. And so that's why you have a widget set that actually, you know, looks like iOS or Android or Material. And so that's, you know, the way that Flutter draws things. But Flutter can also interact with native code as well. What Google tries to do is to give you a great dev experience. They know that you don't have to use Flutter because you've got the platform tool, so they want to make you want to use Flutter by giving you a good experience, lots of tools that help you, profiling, debugging, so that's pretty nice. And with developers, it's the most popular tool already. I measure popularity for my monthly newsletter. And so I can see that with developers, with various metrics, and you find them on the talk page, it's the most popular one. With employers, I look at job ads at Indeed worldwide. It's catching up to React Native. React Native still leads there worldwide, but Flutter is catching up. So since we run on all these different platforms, can we actually build an application that looks native on each of those platforms? And yes, we can do that. On my talk page, you find a link to a sample application that does that. So that application looks like a native iOS application on iOS. It looks like a native Android application on Android. It also looks like a Material web application. It looks like a Windows application. And it also looks like a macOS application. So all of these things with one application, and you find the sample app on GitHub, and the link is on my talk page. So we need cross-platforms because the native SDKs are too expensive. The web is the most popular cross-platform stack. Got lots of developers, but it's hard to learn. So if you've got a team, a backend developer team laying around and want them to build front ends, then you can use something like Flutter or Xamarin or React Native. Flutter uses Start as the language. It is declarative, and it gives you the option to build native UIs for all these different platforms. And so we're done with our first part. Now let's talk about what I learned using Flutter in my project. I'm the co-founder of a little startup called Your Home in Good Hands here in the UK. And what we are is a software as a service for people that employ cat sitters. And so what's the business value? Really, it's workforce automation. In the end, you want to remove friction and reduce communication issues with people going out. In the end, whenever two or more people work together, it's always who does what, by when, and how. And that's an app that solves that specifically for cat sitters. I wrote all the code. So we've got a backend here. Our app has a backend with Java and Spring and our own database, pretty standard. We also use Google Firebase. I'll be talking about that in a second for authentication and files. The managers use a web application built with Angular to manage customer data and schedule stuff. And the cat sitters then go out. They've got a mobile app built with Flutter, and they go ahead, do the visits, know where they have to go, and then push buttons to say that they're done. So Flutter on mobile, the first thing that I learned, Flutter on mobile, giving a thumbs up. Why? In the end, you don't get two apps for the price of one, with iOS and Android, but I would say you get two apps for the price of 1.25. So, it's still a lot better than building two separate apps. So thumbs up. You get access to all the native libraries. With Flutter, you can call into native code. So there's lots of Flutter plugins written in Dart, but if that doesn't work, then you can always call into native iOS and Android code, and that's how you get access to pretty much everything that the platform has. You get the native look and feel. It can look like iOS, it can look like Android, and the build and deploy is even faster than native. On my talk page, you find a link to video where you can see when you save something within a second, your app, you save your code, and within a second, your app is updated. So that's faster than what you typically get with iOS and Android development. On the web, I cannot really fully recommend Flutter on the web. Why? Number one is the only UI that you get with Flutter on the web is Material UI. On the web, you've got a gazillion different libraries and skins and design systems that you can use. On Flutter, you just have Material UI and have to customize it. So that's a downside. But the bigger downside is on the web, the libraries are written in JavaScript, and you don't get to these JavaScript libraries from Flutter. On mobile, you get to the native libraries. On the web, you don't. So you're restricted to the Flutter libraries that you get, and that's 20, 30,000 versus like 1 million NPMs or something. Flutter on the desktop is also meh. Number one is, why do you even want to build a desktop app in the first place, right? For most people, a web app is good enough, so you probably shouldn't be doing that. But if you do, then these skins that make it look like a real Windows or Mac app, they're actually third party. They don't come from Flutter, so they're not complete. For instance, on macOS, you don't have a drop down, and because it's an open source effort, will they still be around in 2 years? I mean, the UI on macOS and Windows, they still evolve, and it's a lot of work. So the good thing is you actually do have access to the native libraries. You can call into C or C++ from Flutter, so that's good. Unfortunately, only Windows is stable as a platform, for about a month. Mac and Linux maybe later this year, but so you're running on a platform that's not fully stable, fully ready for production yet. I used Firebase. Firebase is backend as a service. I use 2 services. There's lots of them. I use 2 services that I told you about, which is authentication, which is free, and storing files, which is not. There's a lot more there. Go to my talk page to find out more. And it has a nice integration in Flutter, so thumbs up there. The thing that I didn't really fully realize is that mobile is powerful. What do I mean with that? I mean, you or your kids, they watch TikTok, and that means we can edit videos on our phone. So if you're used to building web applications and you're trying to figure out what you can do or not, these things are really powerful, right? So that's what you have to remember. They're powerful, and that means you can do things that would otherwise be not possible. And really, it kind of comes back more to old Windows client development than being a rather slim web development. So that's why what I would say is store data locally. You don't have any limits there, really, practically. On the web, you're limited to about 50 megabyte that your app can save. Here you've got a gigabyte or 2 or 3, so you can go ahead and knock yourself out. So in our case, we store pictures and videos and everything, something we couldn't do on the web. And you can do stuff in the background, right? You can load data in the background, store data in the background, and make it easier for your users. My app is a workforce automation. I fight for every second, every click, and so if I can download something in the background or save something in the background, that's something that hopefully will entice cat sitters to pay me money. And yes, you can do that on the web as well, and you find a video of me doing that 2 years ago. But it's harder on the web than in Flutter, and you cannot do it all. As I said, you can only store about 50 megabyte as a web application, whereas as Flutter, you can store as much as fits on the phone. What you also want to do is avoid UI out of sync issues. I'm not sure whether there's an official term. That's what I called it. And I want to give you 2 examples. The first one is from a German sports app called Kicker. It's the most popular one. And they reported my favorite team scored a goal, which is Bayern Munich. And you can see the 1-0 down here. You can see the 1-0 there. But if you look up, it still says 0-0. So you're looking at the app, and the app doesn't make sense. Is it now 1-0 or is it 0-0, right? It's the most popular sports app. What everybody wants to use it for is to know the football score. And they can't tell you that. After 10 years in the App Store, they still can't tell you what the football score is. Here's another one, the macOS App Store. I just added some money to my account, which means my balance was now $113. But if you look closely on the bottom left, you see it's $38. So what's my balance now? Is it $38 or is it $113? Here, the most valuable company in the world can't tell me how much money I gave them. That's embarrassing. So you don't want to have that. So how can you actually avoid that, right? So there's lots of different ways. The way that I went about it is to say you have one source of truth, one source of UI truth. What that really means is you've got one global data store in your app. And then when you change that, your entire UI updates. And Flutter makes that easy for you so that it's not very expensive. It makes your UI sluggish. But that doesn't really always get you there. There's still something that can take you down. And that's what I called status duplicates. And I'm going to give you an example here. So that's the mobile app. I've got a list of visits that a cat sitter has to do, but here on the home page, I give you an overview, right? This is how many visits you finished today. I stored that as data, and then all the visits were stored separately. And sometimes that could go out of sync because I finish a visit and the user comes back to the home screen, but the status hasn't been updated yet. So what's the solution? The solution is I don't store the status separately. Instead, I calculate it in real time. So yes, every time you hit the home screen, I go through over 5,000-6,000 visits to figure out how many of them were your visits that were finished today or this week. That sounds like a waste, but it isn't, because remember, I told you mobile is powerful. You can do that. So as a trade-off of using more power, you can actually avoid UI sync issues, the status telling you something different than the lists. Okay, so avoid status duplicates. And if you store all the stuff in a data store, that helps you when you're offline, because most of your data is offline. You don't have to wait for the web to be available to download stuff. The other thing is that I learned respect paradigms but share. You may remember that I built a web application, which you see here, and I built a mobile app. So some people use both. So you want to respect the paradigms, which means that on the web you've got a tab bar there, and on mobile you've got a bottom nav bar, and you can see. So respect the paradigms, but you can share stuff. What can you share? If you look over there, you see I use certain icons. The walking man, I use fonts and I use colors, and you can use that same font, icon, and color in the mobile app so that it looks familiar to somebody who is using both. So what it means is you want to be consistent, you want to respect the paradigms of the platform, but you can share. You can share colors. I use the brand colors, and I used Bootstrap, pretty popular open source framework. You can share fonts. I used Google fonts. They're available on both web and the Flutter. And share icons. I use font art. There's other icon libraries. And the last thing, back to basics, right? No matter whether you build software, there's always some things that apply, which is number one, the best code is the one that you don't have to write. So reuse code. There's lots of nice plugins for Flutter. Use them. Number two, dry, don't repeat yourself. So create your own components. It also helps you with styling stuff in the Flutter world. And you want to give this whole thing a structure that, so that you can maintain it and you can find details on what I did there in the app. Okay, so that's what I learned about Flutter, and that means it's now summary time. So first part, we talked about cross-platform. We need cross-platform because native stuff, the web is the most popular, the biggest stack with lots of developers, but hard to learn. If you've got backend developers, then a no web cross-platform stack is better for them. It's Flutter, Xamarin, and React Native in that area. And then Flutter is I think the best option for mobile at the very least. And you get declarative. It's a declarative framework. You use a start, which is quite familiar. Lots of going back to the basics. You want to reuse code. You shouldn't repeat yourself, and you should structure your app so that you can actually maintain it. And in the end, all of that together hopefully helps you building better mobile apps. If you go to that page, then you can find the slides, you can find the videos that I talked about, you find some extra information. You can get links to getting started with Flutter. There's like a language, there's a Flutter language tour, Dart language tour for Java developers. I think there's one for C# developers as well. Lots of courses, stuff like that. The native UI sample project, the one with the form that looked, native in 5 different platforms. Find the link there as well. And you can give me feedback and subscribe to my newsletter. Thank you.
Thank you, Karsten. Thanks for sharing your findings on Flutter with us. It was really, really interesting. That kind of concludes our second GDG MK event. Thank you to our 3 brilliant speakers. Really, really enjoyed that. There were so many positive nods throughout the audience whilst you were all speaking, so I think that's a brilliant sign. Just a quick one, if you are interested in giving a presentation at our next event, which will most likely be in a month's time, please do get in touch. Tomorrow, we've also got GDG Reading, who are hosting a Study Labs event. If you're interested in attending, I think you can join by gdg.community.dev. I hear there's something about free Quick Labs credits, so if that interests you, please head over there. But thank you, everyone. Looking forward to catching up with you guys now. And thanks, everyone, for joining the live stream too. Thank you.